All right, and welcome to Code Corner. This is a video series we like to do at Mayfield Renewables where we talk about codes and standards as they relate to the solar and solar plus storage industries. Today we're going to focus in on the 2023 NFPA 70B, and we're going to talk about grounding and bonding as it relates to 70B. So 70B is the standard for electrical maintenance, equipment maintenance for our electrical systems, and in 2023, Chapter 30 was added, and so it talks specifically about PV systems. And so want to talk about what some of those tests look like and what some of the tools are that you can use and kind of what it is that you're out there looking for when you're doing these. So first off, let's take a look at table 30.4.5. This is a list of PV system electrical tests. And so you can see there they talk about different test types, and so 70B gives you more information on that, kind of gets into more of those details. But number 2 there is grounding and bonding, and what you see is in the notes that there's a variety of ways that we can use, what tools we can use, methods we can use to do these tests to verify our grounding and bonding. And so as you're going out and you're doing these things, you'll need to follow certain protocols from the manufacturers. 70B is laying out specific timelines on when you would be going out and doing these tests, the intervals between them and things like that. And so we're going to focus into talking about the grounding and bonding, what some of those tests are. So, the contact resistance, fall of potential, point to point, depends on what the grounding system is that you're testing for. And so, we're going to, focus in on contact resistance and these earth testers, these digital earth testing tools that you can use. And so here we see a couple pictures. That first one on the left is a digital low resistance ohm meter. We'll show you some more about that here in a few minutes. So digital low resistance ohm meter, what it's able to do is, in short, it's able to inject a small amount of current into the system under test, and it's actually able to measure and calculate resistance based on what the actual conditions are. And so this is a great handheld tester to use when you are trying to verify bonding or continuity of electrical equipment that is spaced apart. One of the benefits of tools like the DLRO is you can use, they sell spools that go, you're able to have 100-meter distance between the two. So this is a great tool where you can actually have, get set up at one spot, maybe it's at your inverter pad or something like that, and you can actually spool out and go check continuity. You can check the bonding, how good is the bonding between the electrical components that equipment grounding conductor is connecting. So we talked about fundamentals on grounding and bonding in a previous video. So if that's unfamiliar, you can go check that video out just to kind of understand the references there, equipment grounding conductor and bonding, all of those things. But a DLRO is a great way of being able to verify that. You're not limited by a small distance like you are with digital multimeters, and it's a higher accuracy test that can be performed with that. What you're looking at there in the middle, the digital earth tester. And so if you have a grounding system, if you are at a larger site in substations, you don't even have to have substations, but if you have a larger site and you have a grounding system that you need to verify and you need to check what that resistance is to earth, using a digital earth tester is a way of doing that. And so there are multiple ways of using it. There's fall of potential tests that could be done with it. And so again, it depends on the scale that you're at. If you're at a multi-megawatt array that does have a substation, it's very likely that you have earth wells, and you have to go in and start verifying those and checking those on an annual basis. So those are just things to be aware of. If it's a standard commercial industrial, it's probably above and beyond what you would be doing in terms of checking those exact requirements. But the earth tester is there, especially if you're having problems, if there's something coming up and you're needing to look at that. And then finally, just kind of a picture there on the right, just kind of showing, the idea here is our grounding and bonding systems on our PV systems, especially as they age, are hopefully they were done properly, but we need to be checking those, and we need to be running tests, and we need to make sure that we are verifying that that bond is still appropriate, that the bond is still in place. So, just kind of showing that, hey, we have these older systems, they can age out, and we can have some problems. So these photos kind of help illustrate that again even more. So what we have going on left or right is, we have a racking system, and you can kind of see those ground lugs that are screwed into the racking system. We have a jumper between those, but if they're not properly maintained, the far right there is more of a close-up of that. You can see where that ground lug, that the set screw, is actually rusting out, and so that's would be highly suspect. Is that a good bond still? This screw that is connecting it to the rail is rusting out, so questionable on even having those connections made. And then you can see inside of an inverter as well. So we have potential issues, especially as these systems age, trying to make sure that we are measuring and making sure that they are truly properly bonded. And there was, using the DLRO, you can actually verify, it doesn't matter rooftop, ground mount, things like that, but you can actually make sure that the components are all bonded to each other. So again, you can use this tool. It has a spool, and I'm going to show you a video here in a minute that kind of shows the use of that DLRO, but it really helps verify those connections and making sure that the systems are properly installed. So next up, we do have a video going to show you kind of just the DLRO in action, and be able to see how that tool works and how you can put it to use using these NFPA 70B requirements. Measuring continuity is an important part of the commissioning and O&M protocols for PV systems required by the IEC 62446 standard. Prior to commissioning and turning on the system, the technician must verify all metal components are electrically bonded. The use of a digital low resistance ohm meter, or DLRO, is a fast and effective way to measure continuity between all non-current carrying metal surfaces. A DLRO injects a small amount of current into the circuit to obtain highly accurate resistance measurements. When used in conjunction with a long test lead, a DLRO can measure continuity between remote pieces of equipment up to 100 meters apart. This test verifies proper bonding of all metallic components and ensures that the ground fault detection devices will be able to operate as intended. To perform the test, a technician should connect the leads to the DLRO meter. Adjacent components should be tested to verify proper continuity. To test components spaced apart, an extension spool can be used. One lead remains connected to the meter, and the other will be connected to the extension spool and clamped to a metallic component up to 100 meters away. Once the clamp is attached, touch the probe on the second lead to the first metallic structure. Press the test button on the DLRO, and the resistance between the 2 points will be measured. Resistance values in the milliohms are expected. Any values greater than 10 ohms should be investigated. Repeat the test by moving the probe to a different metallic component. Record all measurements. All right, so that video is something we did in conjunction with Megger as part of this electrical testing standards guide that we've been developing with them. And I encourage anybody who's interested to go take a look at it. There's a link there where you can go download the guide, the parts of the guide that are available at this time. And if there's parts of it that are of interest, if you have questions or comments, we are looking for feedback from the industry. So we're continuing to work with Megger on this product, and would love to get the feedback from the industry to make sure that we're producing a guide that is of most use for the industry as a whole. So take a look at it and let us know kind of what you think. And then just want to make people aware as well, at Mayfield Renewables we have a set of workshops that are available on our website. We have online classes that you can take on demand. They're NABCEP accredited, and so We cover a variety of topics. Codes and standards are highly a big part of what we do, but we're constantly adding new classes as well. So take a look at those. If there's something that we can do for you, if you or your team are interested in an in-person or live class, that's something that we can also help support you and your team on. So love to hear from you and see if there's a way that we could support you and on your education needs. And then finally, if there's any questions or comments on this video, other Code Corners, or if there's topics on Code Corners that you'd love to see covered, feel free to reach out. Always looking for input, how we can be of most use. And so appreciate your time and hope to see you soon.